Hello guys, and welcome to a new video. I was thinking for quite some time what to make as our new project, and then one day driving home I stopped at a traffic light and got an idea. Hey, let's make a traffic light. So here is a traffic light tutorial for Blender. Let's get started. Let's start with modifying the default cube. Let's change the size of it to 1 meter on the z-axis, 5 centimeters on the x-axis, and 0.3 meters on the y-axis. Now let's apply a scale, apply all transformations, because I want to bevel the corners, and if we didn't apply the scale, that would make a bit of a mess when we make the bevel. So let's bevel it and actually change the width to 0.025. Change the segments to something higher to a higher number so that the corners are rounded to 4 maybe. And actually let's make the bevel a little bit bigger, 5 centimeters. Okay. Now back in the object mode, select right click and select shade auto smooth, add a bevel modifier with some reasonable amount, 5 millimeters. That looks good. Okay, now let's rename this as a backplate and add another object, a cylinder. Let's change down the number of vertices to 16, radius to 0.125 millimeters, depth to 0.13 meters, 130 millimeters, and let's rotate it 90 degrees on the y-axis. 90 degrees, okay. Now let's select the back face of the cylinder and move it on in the positive x direction, and select it again and actually delete the face. Now insert the front face once, twice, so that it's quite uniform, twice, and 3 times. Click again and insert it 3 times. Now let's activate the proportional editing tool and move the smallest face a bit outwards and change the proportional size so that we create this sort of a lens shape. Okay, let's move it outwards, and that looks pretty good to me. Okay, now back in the object mode, right click shade smooth and add a solidify modifier. Now hide actually the backplate so we can see it will be the glass cover of the traffic light in full. Change the thickness to 5 millimeters and actually let's apply the solidify modifier. Back in the object mode, let's apply the solidify modifier so we can modify the cover further. Okay, now let's add some edge loops in the back face. We will return to them shortly. Add some edge loops on the sides so we have these nice tight corners also on the inside, and on the small rear faces. So one here and one there. Great. Okay, now let's select every other edge loop. Click the offset edge loop cut, move it outwards a little bit, then select the original edge loops, dissolve them, and now select the newly created phase loops or phase rings. Okay, 1, 2, and 3. Now extrude them inwards. This will create a refractor sort of for this will be a glass, and it will create a refraction of the light on the surface of the glass. Okay, let's add a subdivision surface modifier and let's rename this as a glass orange. Now we can unhide the backplate Actually, hide it back. Now I will add another cylinder. This will be a reflector or a parabole of the light. Let's rotate it with 90 degrees and scale it on the YZ plane so it fits inside of the glass cover. Now let's scale it down and move the face so it sits inside of the glass cover and hide the glass itself. Now again, let's insert the front face of it once, twice, 3 times. And again, with the active proportional editing, let's move it outside to create this sort of a parabole. Now, for the back face, let's select it and insert it once, twice, and now merge the faces at center. Let's add some loop cuts to tighten the corners again. And in the object mode, right-click, shade smooth, and add a subdivision surface modifier. Okay, let's rename this parabole orange. Great. Now we can unhide the glass cover, and let's toggle on the X-ray. How far we can move it on the X-axis so it sits inside of the glass cover itself. Okay, now let's set the origin to geometry for both the parabole and the glass orange, and let's move both objects so they are attached to the backplate. Okay, I see there is a little gap between the glass and the backplate, so actually let's prolong the cylindrical part. Select the vertices and just move them in the negative X direction. Okay, but actually let's deactivate the proportional editing to move them straight. Okay, back in the object mode, toggle off the X-ray, and now actually add one more cylinder. This will be a shade for the glass or for the light. Let's move it a little bit outside. Now select the front face and make it a little bit shorter. Toggle on the X-ray mode, select the back face, and now also select the side faces, the bottom part of the cylinder, and delete them, so that we have only the sides or the top part. Now in the object mode, let's scale it a little bit outside on the YZ plane, and actually let's add a solidify modifier. So subdivision surface modifier first. Let's add a subdivision surface modifier first, and we will apply the solidify modifier afterwards. In the edit mode, let's select these corner vertices and move them a little bit downwards on the Z-axis, and add a loop cut so that the corners are nice and sharp. 1, 2, 3, and 4th on the opposite side. Okay. Now we can add the solidify modifier and actually change the offset direction so it's solidified outside. And let's shade auto smooth and change the thickness to something smaller, like 5 millimeters. Okay, and a final modifier, let's add a bevel here. And again, add some reasonable number to the amount, like 1 millimeter, maybe. Yes, that looks okay. Now, actually, we can duplicate the we can duplicate the elements. Let's rename this as shade orange and hit Ctrl D. Ctrl D, drop the tool and move it with 0.325 meters on the z-axis. Let's rename it shade red. Ctrl D again. Let's rename it shade green and just change the sign on the z-axis and it's pretty much mirrored. Select all the three shades, also the backplate, and hit the P to parent the shades to the backplate. Now let's duplicate the parabole again with Ctrl D, position it 0.325 meters on the z-axis, rename it to parabole red, and Ctrl D again, rename it to parabole green, and change the sign so it's on the bottom of the traffic light. Now let's actually parent all the three parables again to the backplate. So select all of them, select the backplate and hit P to parent it. Now the last item to duplicate is the glass cover. So Ctrl D again, drop the tool, rename it to glass red, position 0.325 on Z. Ctrl D again, rename glass green and position it to -0.325. Okay, and one more thing to do is actually to prolong the shade red because the top shade for the red light is usually a little bit longer, so let's just select the vertices, but obviously we didn't select it through, so let's undo that. And now actually turn on the X-ray mode and select all the vertices and now move them on the X-axis. And now as I see it, I actually would like to prolong the other two shades a little bit more. They seem too short, so let's actually delete the shade green. Select the shade orange, select again the front vertices and move them a little bit on the x-axis. Now back in the object mode, let's just reduplicate it and set the position on the z-axis to -0.325 and let's rename it to shade green. Now let's parent the let's hide actually the turn of the X-ray mode and let's hide the glasses, and now we will add a light source. It will be another cylinder mesh. So let's add a mesh cylinder, change the vertices to 8, rotate it with 90 degrees on the y-axis. And now let's scale it down on the YZ plane. And obviously also on the x-axis to create this flat surface. Now let's add a subdivision surface modifier, select shade smooth, and let's position it so that it sits inside of the parabole and doesn't interfere with the glass covers. Okay, so that will look solid when we render it. Now we can rename it as a light orange, and let's duplicate it and change the name to light red and position it to the usual 325 on the z-axis and the light green -0.325 on the z-axis. Okay, now let's parent the green light to the green parabole, orange light to the orange parabole, and red light to the red parabole. And the same for the glass covers, so glass red to parabole red. Select the parabole, hit the P key to parent it and to object, and the same for the other two. So glass green goes parented to parabol green, glass orange is parented to parabol orange. And let's check if it's assigned correctly. Yes, that looks like it's okay. So the orange is to orange, red is to red. Okay, now that model is complete. Let's go to Shading tab and add some materials. Let's select one of the models, doesn't matter which one. Hit F to frame it to view, and let's assign IDs to the glass covers. So the red one will have index 1, orange will have index 2, and green will have index 3. And let's do the same for the light sources. So select the light green, assign it pass index 3. For the orange light, let's assign index 2. And for the green light, for the red light, let's assign index 1. Okay. Pass index 1. Because the light and also the glass material color will depend on the index. We will not create separate materials. It will be a universal glass material and universal light material. So first things first, let's make a black plastic material for the backplate and for the shades. It's nothing fancy, just a simple material with dark gray black color and decreased roughness. You can find tons of tutorials on great plastic materials. Let's not get delayed with it. So let's also assign it to all the shades, and now select one of the glass covers and assign a new material to it, which we'll call glass. Now add a object info node. We will need that to retrieve that index that we assigned previously. Now add a color ramp. And another node that we need is a map range, because the color ramp operates with the value from 0 to 1. So we need to actually change the index from 1 to 3 to, let's say, or to normalize it to value from 0 to 1. Now we can plug the result into the factor and the color to base color. Now also assign it to the rest of the glass covers. And we can already see that we have this smooth transition from black to white on the glasses. So let's actually change the colors. The first one will be red. So red will be 1, the other values will be 0. Now add another stop at 1/3. 1/3. Change the color to yellow, orange to orange. Okay, add another stop at 2/3. This will be a green color. So change the value 0 on the red and 1 on the green. And the last stop has to be green as well. Okay, now change the mode to constant, so the colors don't bleed to each other. And the colors are already assigned, so now let's just make it a transmissive material, decrease the roughness to 0, and just change the transmission roughness a little bit to 0.1. Since we are in the material preview, we can't see much, and we need to, for Eevee, we need to enable the screen space reflections and also refractions. But also we have to enable it on a per material basis. So let's go to Material tab and enable screen space refraction. This will make the material transparent. Also, we have to change the blend mode to alpha blend. Eevee is not really great at rendering the refractive materials. Let's actually go to the rendered view, and we will need an environment. So let's actually choose one of the Blender default environments. Let's open the Blender folder, the default Blender folder in. I still have a 3.4 version, so let's go to Data Files, Studio Lights, and I will choose a city background. So now in the render tab, I will actually switch to cycles because the glass is rendered much better in cycles compared with Eevee. Obviously change it to GPU compute if you have the possibility to have the fastest result possible. Also turn down the samples and let's have the denoiser work. Okay, now actually let's select one of the parables and add a new material. It will be a let's call it reflector. It will be a shiny metallic material, so metallic value all the way to 1. The base color can stay this silver white. Roughness, let's turn it down to some small value so it's really shiny, and we'll add a simple checker texture to create a bump map. Let's actually hide the green glass so we can see it better. Now add a bump node to convert the grayscale texture to proper normal map. So plug the normal socket to the normal input of the material. Now add also a texture coordinate node, and we will use the object coordinates or object vector. And also what we need to do is to turn up the scale so that the checker texture is quite small. And also turn down the distance and strength because the effect is too extreme now. So let's change the distance to 0.001 and the strength to 0.2. Okay, now let's also turn down the roughness to 0.1. It has to be really shiny as a reflector. Let's unhide the glass green, and now we can assign it to the other parables. Okay. So select the parabol orange and assign it the reflector material, and the same for the red parabol. Okay, with the materials assigned, now we can get to creation of the light material itself. Select the green light and add a new material here. Let's call it traffic light, and actually assign it to the other light sources as well, so to the orange light and to the red light as well, and assign the traffic light material here. So let's make some room for the node setup actually. Add a value node. Let's enter here hashtag frame. This will be a source of clock for our time cycles. Add another node, a math node here. Change the function to wrap. This will be a time cycle for the orange light flashing. We'll do that one first. Add another value node, and let's rename it mode. This will switch between the orange light flashing and the classic traffic light operation. Now let's plug the frame to the value input of the wrapper node and change the maximum value. Actually, let's set up the scene frame rate. For me, it's 25 frames per second. And let's change the maximum value of the wrapper to 30 and the minimum to 0. Now add another math node. Math node. Plug in the wrapper output to the value and change the function to less than. We will threshold set up to 15. It will return 1 for half of the cycle and 0 for the other one. Now what we need to do is to retrieve an object index value. So add the object info node, then another math node, change it to compare. Let's plug in the value to the value, but actually let's duplicate the math node and plug it in between, we need to assign to the result an object index. Object index of 2 for the orange light, and then we need to compare it with the actual object index with a epsilon or tolerance of 0.1. Let's plug in the result of the comparison node to the emission strength and change the emission color to white. Now let's add here a timeline, so horizontal split, change the window to timeline, so we have control over the playback of the scene, and change the end frame to 350 frames. To boost the light output of the math nodes, let's add another math node and change it to multiply and set the value to 10. This will boost the light output. So now you can see that it's already flashing. Let's get that mode value working. Add a math node here. We will set it to compare. Let add math. I always write compare when I want actually a math node. So add that math node here. Let's rearrange the nodes a little bit to make some room. Connect the value to of the mode node to the input socket of the math node, and let's change it to compare. The epsilon set it down to 0.1, and the value will remain at 0 that we compare it against. So when the mode is at 0, we will and the result is true of the comparison node, we will multiply the previous comparison of the indexes with a result of this compare node, and it will be either 0 or 1. If it's 0, the orange light will not be lit. If it's 1, it will be lit just as it is. Let's rearrange it a little bit more. Now duplicate the wrapper node, and let's make the classic traffic light operation. The length of the cycle here will be 350 frames. Let's move the mode to the side now, and let's also duplicate the less than mode and plug in the wrapper, and here it's the first interval of the traffic light cycle. We will end with frame 100. This will be for a green light. So what we need to do is to multiply it by index of the green light, which is 3. So again, duplicate the comparison node to compare the object indexes that we obtained from the multiply node, and to make it actually work with the mode node, we have to invert the result of the comparison node. So when it's not equal to 0, we need this value to be true. So now again, let's add a multiply node and multiply the result of the comparison object index comparison with the inverted value. And to combine the orange flashing and the traffic light, we will simply add a add math node. So the add node works as a logical OR, the multiply here works as a logical AND. So when we change the mode to 1, we can see that the green light is lit up to a frame 100 that we set in the first interval. Beyond that, it's not defined, so no light is lit. Now for the second interval, it's a transition from green to orange, or the orange light is lit. It will let's change the less than to a greater than, and plug in the output of the wrapper and change the threshold to 99. Now duplicate the multiplication node and duplicate again the greater than node, and now set it to less than. This will be the top limit of the orange light interval, and let's set it to 175. Let's plug in also the wrapper output here, and to obtain the interval, we have to multiply these values together. So both of these values need to be at 1 in order for the orange light to be lit. The orange light index is 2, so let's enter to the value of the multiply node 2. Now duplicate the comparison node, plug in the object index output of the object info, again plug in the result of the multiplication, and as usual, to combine it, we need an add node, and just simply add the result of the green light and the orange light together. So let's duplicate the add node, plug in the first result of the comparison, the second result of the comparison, and plug it instead of the original node. Now let's switch actually the nodes so that the links are not crossed. And now when we move beyond frame 100, the orange light gets lit. So it continues up to frame 175, and beyond that, again, it's not defined, so it's not lit. Now we can duplicate the two greater than and less than nodes. Let's copy the greater than node. First, the start of the interval when the red light is lit, which will be at 175. Now duplicate it again, and it will go up to frame 250, I think. Yes, maybe we'll see the length of the intervals, and actually the start of the interval needs to be subtracted 1 frame, so 174 is the start frame. Now again, they both need to be multiplied together, and now we need to assign an index of the red light and compare it again to the object index information from the object info node. Now add them again together, so we have all the lights lit. It's a giant, not a giant, but a logical tree. It's a logical tree of ANDs and ORs. It's nothing too complex. Let's see what we have. Beyond frame 175, we have nothing. We have nothing because we didn't plug in the object index actually to the last comparison that we added. Now we still don't have anything because the index of the red light is actually 1 and not 3, as I entered here before. So beyond 175, we have the red light lit. Now let's also actually plug the wrapper node. I was quite sloppy here with the connections. So, okay, let's check it out again. Beyond frame 250, we should go. Beyond 200. Beyond the frame 250 we should go, and there it's not lit. Okay, so that will be the final interval when we get both the red light and the orange light on. So let's duplicate the greater than, and it will be greater than 249. Let's plug in the wrapper so we don't forget. Now we need to first multiply it by the index of the red light, so multiplied by 1. Let's plug in the value and enter here the index of the red light, so that's 1. And again, for the orange light, we need to multiply the result of the greater than node with 2, which is the index of the orange light. Now, again, two comparison nodes. So let's duplicate them, plug in the object index node. Now, one more duplication, one more compare node, and plug in the object index 2. And again the object index of the object info node. Add them first these two together, and then with one more add node, we will we will sum all of them together and plug them to the final multiplication or enabler of the traffic light mode operation. So beyond frame 250, we have both the red and orange light lit. Okay, let's actually pass the cycle completely. So change the end frame to 700 and let's play it. Let's play the animation. Let's make it a little bit bigger, the window. And let's see what we have here. Beyond frame 250, it's returning to the green light, and the cycle gets reset after the 350th frame. Okay. Let's rearrange the workspace again, so we have enough room for our nodes. And now I'll make the traffic light operation parametric, because I wrote all the constants here, but let's make it parametric. So duplicate the value node and rename it green duration. Now copy again and let's rename it red duration. And yet one more copy, and this will be a transition duration. Okay, let's enter the actual frames here. The green will be 100. I see that I renamed the wrong one, so let's move it upwards. The red will be 100 as well, and the transition duration will be 75 frames. Let's move them to the side, and to make the complete cycle duration, we will need to multiply the transition duration by 2 and add the green duration and red duration to get together, and then add the two transitions on top of it. So duplicate another math node and add the green and red and the two transition durations. Now we can plug the result to the max value of the wrapper of the time cycle. And for the first interval, we can plug directly the green duration period. So let's plug it in. For the start of the next interval, what we need to do is subtract 1 frame. So subtract 1 from the green duration and plug it to the threshold of the greater than node. Then for the end of the second interval, we need to combine or add the green duration and transition duration. That the result we can plug to the end of the second interval. Now the start of the third interval, we need to subtract 1 from the previous result. So let's copy the subtract node, plug in the result of the addition, and plug it to the start of the interval. Then again, what we need to do is to add one more transition to the cycle. So add the transition there, plug it into the result, or in the end of the third interval, and for the start of the last interval, we need again to subtract 1. It was that simple. So now it's parametric. And actually, let's also make parametric the blinking or the flashing. So let's rename it as blinking duration. Blinking duration. Set the value to 15. Now add a math node. Set it to multiply. We will multiply the blinking duration by 2 and plug in the result into the wrapper max value, or the time cycle max value, and the blinking duration period will be plugged straight into the less than. So these are parametric now, and actually I think let's let's play it. Let's play it. If it's working correctly after we enter the params here, and it seems to be working just like before. Okay, and at 350 it gets reset. Okay. So let's get back to frame 1. Let's add actually one more value node, and let's rename this offset. This will be useful for when we want to have additional traffic light with different timing. We don't want it to start at the same time. So actually I renamed, I think, the wrong nodes. So let's add the offset to the current frame. I renamed the wrong node, so let's let's fix that. Actually, the offset is offset now, and let's add the offset to the current frame and replug it instead of the original frame outputs. So let's see where it goes. It goes to the first, just to the first and second wrapper. So let's replace the connections. First one and second one, and I already see that it screwed up the connections because it replugged also to the min value. So let's get rid of that. Let's see where it gets plugged in. Let's separate that connection. This one is okay, and also let's separate the min connection. No, now that one, and let's replug the blinking duration to the less than node. Okay, let's play it. Change the offset. For the moment, we can actually reset, zero out the offset. We don't need it at the moment. We will get back to it later. Okay, seems to be working. One more thing I did wrong. Actually, the last interval should not be added a transition duration, but red duration. So let's replug it, and now it should be fixed. To make it a bit more user friendly, let's actually select all the nodes, right click, and select group. Now what we will do is to replug the connections from the value nodes to the group input, and let's rename it in the group tab. So the first one was the mode. Let's rename this mode and change the default value to 0, minimum 0 it out, maximum will be 1. Now let's delete the mode and replug the green duration by control and clicking, or control drag it to the input, and let's actually undo that because I dropped it unintentionally. So let's replug the green duration, delete the node, and let's rename this socket to green duration. Now let's replug the blinking duration value. Instead of it, it's blinking duration. The default value is 15, maximum stays as it is, minimum is 0, and I forgot to set up the values for the green duration, so default 100, minimum 0. Let's get rid of this node, replug the offset, change the value, again rename it to offset. It's the same drill all over again. We can rearrange the order of the sockets, because it makes more sense that the mode is first. So for the offset, again, the default will be 0, minimum will be 0, maximum can stay as it is. Now let's replug the red duration, and rename it. Again, default 100, minimum 0, maximum stays as it is, and finally the transition duration. Okay, and let's rename it. Transition duration. Default is 75, minimum is 0, maximum stays as it is. Let's get rid of these two nodes, we don't need them anymore. And now for the output, actually delete the material output node and connect the BSDF socket to the group output. And now let's get one step up out of the group and add the material output here and plug in the BSDF to the surface. Now we get the lights, but obviously the values are all screwed up. So let's change the mode to 0, offset to 0, green duration to 100, blinking duration to 15, red duration to 100, and transition again to 75. Now, actually, I don't like the order of the sockets. The blinking duration should be right below the mode, and the offset should be the first value to enter. Okay. So let's play it out. This one is the orange flashing. Let's switch it to the mode to the traffic light, and it has a smooth transition between the modes. So let's actually duplicate the entire hierarchy. Control D, hit escape, and then move it on the y-axis. Select one of the light sources from the newly created object. So select the green light 0.001 and duplicate the material. Now the only change here will be the mode will be 0, so the orange flashing, and let's also assign the material copy to the rest of the light sources. So also to the red light. See, now we have two independent traffic lights, with one working in the normal mode, the other one in the orange flashing. And let's duplicate it again. Let's make another copy of that. So select all of the objects, Control D, drop it and move it to the other side on the y-axis. Select the light source, make a copy of the material with the suffix 002, assign it to all the other light sources, again the same drill. And here what I will change is the offset mode. So this will start with a different color. So at an offset of 175, and it will start with a red light. So as the original traffic light is transitioning to the red, the other one is transitioning to the green, and the traffic light on the far right side is flashing orange. And this is it. And that's a wrap for today. Thank you for watching. If you like the content I'm creating, make sure to hit that subscribe button to get notified when I release a new video. See you at our next project.